Welcome to geometry. We will be talking about angles. There are different ways to name angles. We will talk about 3 of them. The first way is when an angle has a number. In this case, you use the angle symbol and the number. Now the number may be here in the center, but it may also be here at the tip, or what's called the vertex. You can also name an angle using letters. In this case, this is angle A. Again, use the symbol A. Now an angle can be named with a capital letter or a small letter. In the past, we have talked about complementary angles. Complementary angles are angles whose measurement add up to 90 degrees, which is a right angle. Now, complementary angles do not have to be next to each other, nor must they share a side. They simply must have a combined measurement of 90 degrees. Supplementary angles add up to 180 degrees, which makes them a straight line. Again, they do not have to be next to each other, nor must they share a side. They simply have a combined angle measure of 180 degrees. Conversely, we have adjacent angles. Adjacent angles do have a common side and a common vertex. So this angle and this angle are adjacent. This angle and this angle are not. Notice the adjacent angles share a side. So this side's shared, and that makes them adjacent. If you have this angle, and an angle that goes like this, the blue angle and the green angle are not adjacent. The blue angle and green angle are not adjacent. They do not share a side. They do share a vertex, but not a side. But if you're looking at this angle and this angle, they would share a side. So the highlighted area would be adjacent, but the previous blue and green would not be. Parallel lines. Parallel lines are lines in a plane that do not and will not intersect. So let's look at these. Example A. Here's our plane, 2 lines, obviously parallel, equal distance apart all the way along. Are these lines parallel? Yes. Why? They exist in a plane, and they do not intersect because they remain equal distance all the way around. B. B is an obvious no. These lines are already intersecting, so they are not parallel. C and D are a little bit less obvious. C is a short line and a long line. Angle C's short line does not change the fact that no matter how long we make it as we extend it on, because lines go on in both directions forever, these will not intersect. They are still equal distance apart all the way along. So these 2 lines are, yes, parallel, because no matter how far we extend them, they still will not intersect. Now looking at D, this answer is a no, because these lines do not intersect, yes, but they're not equal distance apart. They get closer and closer as we move farther to the right. But as we extend these lines out into the future, forever, they will eventually intersect. Now, I said parallel lines exist in the same plane. A plane, in math, is a flat surface, 2-dimensional, that continues forever in each direction. So a plane will continue in 2 directions forever. In every direction is an easier word to write. Every direction forever. So this will go forever this way and forever this way. Again, think of a thin piece of paper, but it goes forever in the 2 directions. But it's not, it's a slice, very, very thin, but 2 directions it goes forever. A line is created when 2 or more planes connect. So here's our line. So a line is created when you have 2 planes. Now, using 2 planes, you can create 2 lines that will never intersect, but they will not be parallel. And we'll talk about that in class. The lines have to exist in the same plane and then be equal distance apart to be parallel. Our next definition is about transversal. In this figure, AB, this is line AB, and PowerPoint doesn't allow me to make these line symbols, so I'm going to add them here, is cutting across the parallel lines PQ and RS. And you can see in this example that many angles are the same, which means they're congruent. And that gets to our topic of our presentation. We're going to have corresponding angles and vertical angles and alternate interior angles. Okay, one last definition, transversal. There's a special type of transversal called a right angle or a right transversal. And if it crosses parallel lines and creates right angles, it's called a right transversal. Now let's move on to corresponding angles. Corresponding angles are angles that result in corresponding locations when parallel lines are cut by a transversal. So that means if we look at angle AEQ, so this is angle AEQ, it goes right here, A.E.Q. This angle, which measures 134 degrees, and I know that because this is a straight line. Straight lines are 180 degrees. 180 minus 46 is 134. So AEQ, this angle corresponds to angle EFS. So this angle, EFS, and they both measure 134 degrees. We have angle FEQ, so let's look at the FEQ, remember E's in the middle, so we have this angle. This angle is 46 degrees, and again we realize that because we create a straight line here, and that straight line must equal 180 degrees. So angle FEQ measures 46 degrees, and it corresponds to angle BFS. Is in the same location, but on the other parallel line. We're now going to look at angle BFR. BFR, that's this angle. BFR, F is our vertex. What angle does that correspond to? Well, that corresponds to this angle. They're in the same location on different parallel lines. So that's FEP, angle FEP. And those angles measure 134 degrees. Again, I know that because this must create a straight line right here. Again, we have our straight line. Our straight line must equal 180 degrees. And finally, let's look at angle EFR. EFR is this angle right here. EFR is the same as this angle right here, which is angle AEP. And that angle measures 46 degrees. Now I've left a couple of them blank. I want you to go through and fill them in. With the color coding, you should see where they belong and where they correspond to, so you can get a feel of this. Make sure you have that done by the time you show me in class tomorrow. We are now going to talk about vertical angles. Vertical angles are angles that are across from each other. So angle AEF is across from, this vertical angle is across from this angle. And vertical angles are congruent. So if we go ahead and we look at angle AEQ, it is vertical to angle FEP. Now I tend to put these in alphabetical order. Quite honestly, you do not have to put them in alphabetical order. This is just as easily could be named angle PEF. What you do need to remember though is that the E, the vertex, needs to be in the middle. Now the nice thing about vertical angles is that they are congruent. So that means once I know that angle AEQ equals 134 degrees, and we know that because there's a straight line, and straight lines equal 180. Once I know that angle FEP also equals 134 degrees. And if I'm looking at angle FEQ, well, angle FEQ is a vertical angle. Well, where is it vertical to? Well, FEQ is a vertical angle to AEP. Since AEP is 46 degrees, both of those also equal 46 degrees. EFS, this angle, is vertical to what angle? Did you guess BFR? If you did, you'd be correct. In the previous slide, we knew that this was 134 degrees because it was corresponding angles. This is 134 degrees, so vertical angle, BFR, is also 134 degrees. BFS, this angle, I just marked in black, must be 46 degrees because we have a straight line. Straight lines equal 180. But once I know the angle BFS is 46 degrees, I also know that RFE, angle RFE, is going to also be 46 degrees because they're vertical angles. I've given you 4. I'm going to leave you 4 more for you to measure or work with. I have a couple of typos. These should each be vertical. We're talking about vertical angles on this slide, so write vertical there and write vertical here. And I'll check those in class tomorrow. Our next slide is on alternate interior angles. Alternate interior angles are angles that alternate, but they stay on the inside of the parallel lines. So they stay inside these 2 lines. So if we look at angle FEQ, FEQ, so we're looking at this angle right here, which we know is 46 degrees because it's a vertical angle to the 46 degree one we have here, PEA. So FEQ is going to be congruent to EFR. And how do I know they're congruent? Well, because they're alternating interior angles. And they'll both measure 46 degrees because they're congruent. They're alternating interior. So they're both on the inside, and see they alternate sides of the transversal. Likewise, we have angle EFS, this angle. Now that angle has an alternate interior angle right here, which is FEP. See how they're alternating interior angles? And both those angles are going to be 134 degrees. So they alternate, they're both on the inside, and they alternate sides of the transversal. So they are also congruent. I'm going to leave you 2 more on this slide to do. They are already marked for you. Let's move on to alternate interior angles. Alternate interior angles are also congruent. Let's look at what they are. They are alternate exterior. Exterior means they're on the outside of the parallel lines, and they alternate over the transversal. So if we're looking at angle AEQ, this angle, which we've already talked about equaling 134 degrees because there's a straight line. Straight lines are 180 degrees. So if we have a 46 degree angle, the other angle must be 134 degrees. Back to angle AEQ is congruent to angle BFR. They are alternating exterior angles. They are exterior to the parallel lines, and they alternate sides of the transversal. So they both equal 140 degrees. We also have angle BFS. This is angle BFS. Well, it's an exterior angle, and it alternates with angle AEP. So angle AEP and angle BFS are also congruent, and they both measure 46 degrees. Like in the previous slides, I'd like you to finish the remaining 2 questions and then continue on. Now we have same side interior angles. These are not congruent, but they equal 180 degrees. Same side interior angles. So if I look at FEQ, we have this angle here. Same side interior angles. So we're looking at an interior angle right here that's on the same side of the transversal. So we're going to measure FEQ with this measurement here. EFS with this angle. EFS. So we're looking at these 2 angles. They are going to equal 180 degrees. Well, if I know they equal 180 degrees, I can determine what angles equal. For example, this one is 46 degrees because it's a vertical angle. And since I know that this transversal is made up of this 46 degree angle and this angle here, EFS, I know that the measure of angle EFS must equal 134 degrees. Because again, we have the straight line theorem, and these 2 equal 180. If I look at angle FEP, I know this one equals 134 degrees. Because that equals 46, again we have a straight line, those 2 angles are adjacent, they make a straight line, they equal 180. Well, same side interior angles, that means I can determine that this angle right here, EFR, together equal 180 degrees. And since together they equal 180 degrees, angle EFR must equal 46 degrees. I want you to go ahead and see if you can determine the measure of angle EFS and what angle is the same side interior to it, realizing they both equal 180. The same thing right here with EFR combined with what angle equals 180, and finish up this slide. And that will be it for today's lecture, and I will talk to you in class tomorrow.